So we're going to talk about values of inverse circular or trig functions. So just to review, so these functions, what do these represent? These represent inverse trig functions. So sometimes people think that this is an exponent. It's not meant to be thought of as an exponent. It's meant to indicate that you're using an inverse trig function. And so in this video, we will talk about using the unit circle with these functions when possible, or using a calculator. So we make some key assumptions about these functions, and the reasons why are for another video. But when a calculator is in radians, it makes these assumptions. So if you're using inverse sine and you're assuming that x is between -1 and 1, a calculator will only return values between -pi/2 and pi/2. If you have inverse cosine and your x's are still between -1 and 1, a calculator will return a value between 0 and pi. And then finally, if we're talking about all real numbers of x, inverse tangent, using inverse tangent with the calculator will return a value between -pi/2 and pi/2. Okay, so using the unit circle when possible is stronger than using a calculator, and I'll show you an example of that as we go along. Okay, so let's talk about a few ways that we use the inverse trig functions. So starting with this first one, so I'm given an interval that my value of s needs to be between, so s needs to be between 0 and pi/2, and I'm given this goofy value 0.3311. So this is a value where I don't know any value on the unit circle that equals 0.3311. So this would be an example where I would use a calculator. And so if you were to set this up, so you would take the inverse sine of each side. And so in doing that, you would get that s is equal to that inverse sine of 0.3311. And so what I get out is 0.3375. Now, this value is okay because it falls in this interval between 0 and pi/2, so there's nothing to worry about here. So when we have to use a calculator, this will usually probably work out in your favor. So maybe you should just take a second to try one of these on your own. So I've got same idea. So my value of s needs to be between 0 and pi/2, but now I've got tangent of s equals 0.2155. Maybe you want to just pause the video and take a second to see if you can solve this one. Again, you're going to need your calculator for this. Okay, so I'm going to take the inverse tangent of each side, and when I take the inverse tangent, I get 0.2123. So again, this falls within the interval, so we are good to go. So now let me show you some examples like where you can't use your calculator, or maybe where using your calculator wouldn't make the most sense. Okay, so here's a perfect example. So I've got tangent of s equals the square root of 3, and check out my interval. My s needs to be between pi and 3 pi/2. Okay, so first of all, square root of 3, this is actually a value that's found on the unit circle. So let me show you how you kind of decompress this. So notice here I've got square root of 3/2 and 1/2. So these are my x and y coordinates. So let's think about this for a moment. Tangent of s is equal to y/x. So if I take those coordinates, this would be square root of 3/2 divided by 1/2. So if I work this out just to see what values do I get, I would take square root of 3/2 and then divide it by 1/2. But we know that dividing is the same as multiplying, so I could just multiply by 2/1. So check out what I get here. This gives me square root of 3. So at that coordinate, I would get square root of 3. So I want to know, are there any other coordinate pairs that would result in the square root of 3? So this one definitely works, and you might have to take a second to look around the unit circle. Maybe you want to pause here to see if you see any other pairs, because there's one other pair that would work. So the other pair that would work would be this one, right? So if I take negative square root of 3/2 divided by -1/2, this will still end up becoming positive square root of 3, right? So I have these two pairs that technically could work as, or would result in getting me square root of 3 as my answer. That would result in tangent of s equals square root of 3. So I want you to notice this, because this is how you use the unit circle with your inverse functions. So you have to reverse engineer the process. You have to look at your points and see what points would give you that answer. And then you look at what radian measures result in that answer. So we have two possibilities in this case. Either my S will equal pi over 3. If I plug in pi over 3, that will result in an answer of square root of 3. Or I plug in 7 pi over 6, and that will result in the square root of 3. Again, that comes from looking at my coordinates, and then after I figure out how I got to that square root of 3, then I pick the radian measures associated with it. Okay, so I've got those, and now this is where the interval comes into play. And this is why like using your calculator might not always be the best, because your calculator is going to make this assumption, right? We just talked about that your calculator would return a value in this interval, which is not the interval that we have in this particular problem. So that's why it matters in this case. We have been given this interval here. Okay, so going back to the unit circle, now I have to think about pi to 3 pi over 2. So on the unit circle, where does that fall from pi to 3 pi over 2? We're talking about this part of the unit circle here. So this is the radian measure for this particular problem that I need, so I can discard this other possibility. So you see how that works? Okay, so let's try this one more time. Another case. So I want to figure out for what value of s will this work. Cosine squared of s equals 1/2. Okay, so first of all, I would really prefer for this just to be the plain cosine function, so I'll take the square root of each side. Now remember, the square root property says that when you take the square root, you have this plus or minus here. This is just part of the square root property. And so now what I want to do is I want to simplify this square root, so I can break this up into plus or minus square root of 1 over square root of 2, so it becomes plus or minus 1 over the square root of 2, and then I want to just rationalize. Okay, so this is where your calculator actually is going to have some issues, because your calculator, if you were to try to just take inverse cosine of this, so remember, your calculator is assuming you're between 0 and 2 pi. That's going to be the only answers that it will give back to you. But in this problem, we need all the answers between 0 and 2 pi. So not 0 and pi, 0 and 2 pi. So now I've got to use the unit circle. And now I need to look for, so we're talking about cosine here. So where are my x coordinates equal to square root of 2 over 2 or negative square root of 2 over 2? So if I go around the unit circle, here's this positive square root of 2 over 2. Here's a negative square root of 2 over 2. Here's another negative square root of 2 over 2. And then here's another square root of 2 over 2. So those are the values that I'm looking for. And now I have to look at all the radian measures associated with that. And those 4 radian measures, those are my answers. So your calculator would not give you that. So the context kind of matters here. And so if you have a question where you can use the unit circle, you're probably going to have to kind of think about it like this. And so that's it for this video, guys. You got any questions, you can always leave me a comment. Otherwise, I'll see you in the next video.